Hi students, in previous video we discussed what is meant by an algorithm and different characteristics of algorithms. Now in this video we are going to discuss what is meant by analysis of an algorithm. What is meant by analysis of an algorithm? So here analysis we can discuss in terms of two things. One is space complexity. One is a space complexity and another one is time complexity. So analyzation, we have written some algorithm which consisting of several steps. So in these steps how can we analyze which algorithm is best algorithm or which algorithm is performance is worst. Okay, so which algorithm is giving average time complexity. That means analysis is nothing but here you can say it as performance analysis. So under this performance analysis, that means performance of an algorithm is measured. How an algorithm will work. So that performance of an algorithm is measured based on two things. One is space complexity and another one is time complexity. Okay. So now in this video, we are going to discuss what is meant by space complexity. What is meant by space complexity? So space complexity is the total amount of memory. What is meant by space complexity? The total amount of memory required to get the result or to execute. The total amount of memory required to execute the program is nothing but a space complexity. Okay. So now in this space complexity, generally we will say it consisting of two parts. Space complexity we can explain in terms of two parts. So what are those two parts? One is fixed part and another one is variable part. One is fixed part. That means the memory is fixed, which is not possible to change. That is fixed part. And another one is variable part. So generally any algorithm space complexity is analyzed based on these two parts. What are they? One is the fixed part. Fixed means here it is a constant. Fixed part and another one is variable part. What is meant by this fixed part? Fixed part is nothing but it consisting of or the variables are independent variables. The variables are independent variables. That means these variables are not depending on other variables. The variables which are not depending on other variables are called independent variables. Now, variable part is nothing but this also called as here instance characteristics. Instance characteristics. Or simply we can say that these are dependent variables. These are dependent variables. That means the variables which are depending on other variables. The variables which are depending on other variables are nothing but instance characteristics. That means here variable part, dependent variables. That means, for example, here you are using like variables A, B, C. Suppose three variables are there, A, B, C. Addition of these three numbers you are calculating. So then this is a fixed part. So this variable occupies one word of memory. This variable occupies one word of memory. This variable occupies one word of memory. So which is nothing but 3 words of memory to add 3 numbers. Why? Because this is fixed part. Fixed, and these are not depending on any other variables. For example, dependent variables or variable part, what does it mean? For example, you have an array variable. Generally, array variable is depending on size of an array. So the memory occupied by an array variable is depending on size of an array. For example, you have taken a array variable, so of size 3. Then this array variable occupies 3 words of space. For example, an array storing, this array is storing 4 numbers. Then the memory for an array variable is 4 words. Assume one number occupies 1 word. What is our assumption? One number means one integer variable means occupies 1 word. For example, our assumption is one number occupies 2 words. Then if you want to store 3 numbers, then 3 into 2, totally 6 words of space. But here we are taking this as only 1 word. One number means 1 word. Okay. So now, like that, if you have n numbers you want to store, then n into 1, totally n words of space. We don't know what is the value of n. The value of n we will give at runtime. Okay, so that's why here this array is depending on size of variable, size of that array variable. So the memory of this array is depending on how many number of elements you want to store in an array. That is called as here variable part. Generally, space complexity is represented with, the space complexity is represented with S of P. What is that S of P? That S of P is space for fixed part and the space for variable part. That here I am writing. Fixed part is nothing but some constant. Variable part, that we don't know. That is depending on the values given at runtime. So that's why that we will write here SP. This is variable part. Okay, which is nothing but instance characteristics. So this is an important. So S of P equal to C plus SP. That means space for fixed part and space for variable part. Let us take an example. So we will calculate the space complexity for some algorithms. Okay. Now, for example algorithm. For example, if we have, the question is sum of 3 numbers. An algorithm is sum of 3 numbers. What is the space complexity for this algorithm? That we will find out. Okay. So now, first we will write an algorithm as usual. See, all this we can calculate if we have written algorithm correctly. Based on that only we will get the correct space complexity. If you have written wrong algorithm, then you won't get correct space complexity. So algorithm should be correct. then only you will get this space complexity correctly. If you have written algorithm wrong, then you won't get correct space complexity. So you have to practice the way of writing an algorithm for the given question. That is important. You should be good in writing algorithms. Okay. So now for this algorithm I am writing. So first we will write algorithm. Sum of three numbers. That algorithm name I am writing it as a sum 3. Three numbers addition we want to do. That means assume these are three integers. Then sum only you want to calculate now. Then simply you can write return a plus b plus c. Or otherwise you can write like sum equal to a plus b plus c, return sum. That also you can write. This is an algorithm. Now how to calculate a space complex S of p. What is S of p? S of p is c plus sp. What is this one? This is fixed part and this is variable part as we discussed previously. Okay. Now what is this fixed part? For this, A occupies one word of memory. Assume integer occupies one word. B occupies one word. C occupies one word. So totally how many words of memory it requires for these variables? So and these A, B, C are, remember, these are not depending on any other variables. We are entering values for A, B, C and we are summing these three. That's it. Okay. So that means these are independent variables. Independent variables means where we will write. So this constant. That is constant now. So constant. So that 3 plus this is variable part. That means depending variable or dependent variables space. Now check this algorithm. Is this algorithm using any dependent variable? No. So simply write 0. So the total space required for this algorithm is simply 3 units or 3 words of space is required. That's it. Simply you can say that 3 words of space. Okay. So this is the same algorithm what I have written, similar, somewhat similar to the algorithm which is present in the textbook. Alice Horowitz, Design and Analysis of Algorithms. You can refer the textbook. Okay. Next, another example. Suppose now the question is, we want to find out a space complexity for sum of array elements. Sum of array elements. Previously sum of 3 elements only. Now sum of array elements. What does it mean? You have an array variable like this. For this array variable, some elements are there like 1, 2, 3, 4, 5, 6, 7. That means n equal to 7 array size. Now the elements are some 3, 4, 2, 1, 3, 2, 4 like that. Now we have to find out the sum of all these elements. Generally, the algorithm for this is we will write the logic. What I said, you have to write algorithm correctly. Then only you will get a correct space complexity. Okay. So the logic for this is sum equal to sum plus a of I, where I is starting from 1 to 7. First position to 7th position. Okay. This is the logic. Now we will write an algorithm for this. And then we will calculate space complexity. So algorithm. So this is notational convention how we will write the algorithm. Algorithm and algorithm name. Here I am taking sum array. To find out sum of array elements, how many variables are required? One is this array variable and another one is size of an array, a comma n. Now we have to calculate sum, no? that sum we have to initialize to 0. So in the algorithm, the assignment operator we will write like this: colon equal to, and then semicolon. So what is this one? This is initialization. Initialization of some variable. Okay. Next, after that we have to calculate sum. So that is not a single element or 2 elements or 3 elements. N elements sum we have to calculate. So loop is required. So for I equal to assignment operator, we will write a colon equal to 1 to n do. In algorithms, in DA subject, DAE, design and analysis of algorithms, the notation convention writing of for loop is this one. Okay, curly brace. Now we have to calculate sum, no? So how to calculate sum? Sum, assignment operator sum equal to sum plus a of I. It repeats calculation of sum for all n elements. Okay. And then finally this is sum now. Now return sum. Final answer I am returning. That's it. This is the logic for calculation of sum. Now for this, how to calculate space complexity. So S of P equal to, you know, our formula. Total space complexity of an algorithm is space for fixed part and space for variable part. Now, first fixed part. Fixed part is nothing but what? Independent variables. Now, in our algorithm, what are independent variables? That means which are not depending on other variables. What are they here? So, independent variables, that means that value is not depending on other variables. Those are nothing but independent variables. Okay. So, now, what are independent variables? Okay. So, now, independent variables are, see, I equal to 1, I variable, correct? I equal to 1 to n, and n we can give some 5, 6, 7 like that. That is also fixed. So n is another variable. That means the space for I is not depending on any other variable. I am telling space for I. Similarly, space for n also not depending on other variable. That means these are simply integers. This is another integer, and another one is sum. Some value is depending on that, but it is also one integer. So that means it occupies one word, n integer, one word, and it is one word. Totally how many words for constant? That means see here 3 words plus variable part. What is variable part in our algorithm? Variable part is an array variable A. This A is depending on the value of n. I explained here na, see. I explained here. If n value is 3, A occupies 3 words. If n value is 4, A occupies 4 words. If n value is 10, occupies 10 words. Like that, this A variable is depending on what? The space for an array variable A is depending on size of an array variable n. Okay. So, here it is depending on the value of n. Okay. So, the variable part here it is array variable. And it occupies how many words? N integers. Each integer occupies 1. So, totally n words of space. So n plus 3 words. Generally, we will ignore constant if n is there. So, the space complexity for addition of array elements or sum of array elements is order of n. Okay. So, this is the space complexity for the sum of array elements. Okay. Generally, it is depending on the fixed part and variable, independent and dependent variables. So this is space complexity calculation. Hope you understand, students. If you have any doubts, so please post your doubt in the comment box. Okay, please share if you like the video. Please share with your friends. Okay, please subscribe the channel if you like the video. Thank you, students. Have a great day. Bye.